Hello everyone, my name is Gideon, and today we are going to talk about Industry 4.0, smart cities, and emerging technologies. Technology is all around us, and it's a major driving force in the changes that we are seeing and experiencing in our society and environment. That is to say that while technological advancements do contribute a lot to the changes that we see today, it is also true that society has been pushing technology to create these changes, as our demands and necessities continue to increase. We rely on technology in our personal lives, from simple acts like changing the TV channel, to our usual home routines like washing our clothes, heating our meals, and even keeping track of our finances. Technology's influence can most prominently be felt in the workplace, where many tasks and processes are becoming digital. If, at first, we find ourselves needing the assistance of machines and technology to accomplish something, now there are ways where we can fully trust these technologies to complete the task. The automation of many manufacturing, production, and creation processes all fall under Industry 4.0, or the Fourth Industrial Revolution. In the Fourth Industrial Revolution, various tasks that we once performed ourselves are now being automated. But before we arrive to automation, there are some groundbreaking steps and other revolutionary changes that led us to it. Like I said, the changes that technology brings society is also triggered by the changes in the society's demands, needs, and priorities. Before automation, we discovered computers. And before we discovered computers, we enjoyed the wonders of using electricity and gasoline in production and manufacturing. Before that is the first time we shifted from handcrafts to manufacturing using machines and power. Wow, we go way back, huh? Well, this journey towards where we are today is actually the whole history of the Industrial Revolution. The first Industrial Revolution dates back to the years 1760 to 1840. During this time, Europe and the United States transitioned from traditional hand production to new manufacturing processes that involve the use of steam-powered machines as well as the use of other tools and power sources. Steam engines were used to power locomotives like the train or the steamship. The emergence of new inventions following the development slowed down until the middle of the 19th century, until its era had finally ended. But of course, that does not put an end to the continuous creation of new inventions and technology. The first Industrial Revolution may have ended, but the machines that were born during this period paved the way towards the start of the Second Industrial Revolution. The Second Industrial Revolution is known as the Technological Revolution and is dated between 1870 and 1914. The contributions of the First Industrial Revolution in the advancement of manufacturing and production allowed the expansion and widespread use of manufacturing machines, which are used to build more railroads and create large-scale iron and steel production. And if the First Industrial Revolution introduced the use of steam-powered engines, the Second Industrial Revolution welcomed the electricity and petroleum power sources. The advances in electricity became the key to the improvement of communication channels and gave birth to more advanced technologies, like the telephone and the light bulb. Ding! Let's also not forget petroleum. Compared to steam-powered engines that allowed the movement of big and heavy machines, the invention of the combustion engine, fueled by petroleum, is able to power smaller vehicles and machines. So we have steam in Industry 1.0, we have electricity and petroleum in Industry 2.0. Can you guess what advancements we have for our third Industrial Revolution? Computers! Finally, computers have made their appearance. The Third Industrial Revolution is also called the Digital Revolution. Yes, we've entered the age of the Digital Revolution, which started in the later half of the 20th century. Now, the third industrial revolution, characterized by the use and rise of electronics and computers, which of course is all thanks to the inventions and advancements in electricity during Industry 2.0, from mechanical and manual processes, we transition to the adoption of digital technology to do different tasks. This is also the start of automating industrial processes and other human activities. During the third industrial revolution, the use of personal computers marked by the rise of mobile phones or cell phones. And of course, let us not forget the internet. The internet. How you and me are talking today. The introduction of computers and IT during the third industrial revolution has laid the foundation for the digital transformation and automation of many traditional manufacturing and industrial practices. And that is precisely why the fourth industrial revolution, or Industry 4.0, is all about. All of the inventions, discoveries, innovations, and advancements achieved from the first all the way to the third industrial revolution has led us to where we are now. Like I said, the demands of society changes. Technology follows suit. In Industry 4.0, we are also looking at the automation delivering goods and services with minimal human supervision. That means not just the heavy industrial and manufacturing processes. Marked by digitalization, Industry 4.0, also called the fourth industrial revolution, is the automation and digital transformation of manufacturing, production, and value creation processes. Industry 4.0 has four fundamental principles: interconnection, information transparency, decentralized decisions, and technical assistance. First, interconnection or interconnectivity. With wireless communication technology and the capabilities of the IoT, you can now connect machinery, sensors, and other devices to the people tasked with monitoring your process for effectiveness and efficiency. This means that the sensors that collect data can now be directly linked to the people that need them. Because this connection is so powerful, data is real-time, evolving, and dynamic. Next, information transparency. The transparency afforded by Industry 4.0 technology provides operators with a vast amounts of useful information needed to make appropriate decisions. Interconnectivity allows operators to collect immense amounts of data and information from all points in the manufacturing process, thus aiding functionality and identifying key areas that can benefit from innovation and development. Third, decentralized decisions. Interconnection and information transparency allow for operators to make decisions both inside and outside of production facilities. This ability to combine local and global information at the same time helps to drive better decision-making and increase overall productivity. Our fourth and last principle, technical assistance. Industry 4.0 shifts the role of humans from an operator of machines to a problem solver and decision maker. Assistance systems are designed to support operators that need to make informed decisions to solve urgent problems on short notice. Now, we can say that these four principles are the foundation of Industry 4.0. These four are creating an impact and making automation and digital transformation not only possible, but also highly effective and beneficial. Because technological advancements are born to meet the continuously changing needs of society, Industry 4.0 also has its main drivers, namely consumer access, digitalization of products and services, and vertical and horizontal integration. Now, let's take a look at vertical and horizontal integration first. Industry 4.0 digitizes and integrates processes vertically across the entire organization, from product development and purchasing, through manufacturing, logistics, and service. All data about operations processes, process efficiency and quality management, as well as operations planning, are available in real time, supported by augmented reality and optimized in an integrated network. When it comes to horizontal integration, we are going beyond the internal processes of an organization. This means all the way from suppliers, we also go beyond and take a look at customers and all key value chain partners. This includes technologies from track and trace devices to real-time integrated planning with execution. Next, let's talk about the digitalization of products and services. Digitization of products includes the expansion of existing products, like for instance, adding smart sensors or communication devices that can be used with data analytic tools, as well as the creation of new digitized products, which focus on completely integrated solutions. By integrating new methods of data collection and analysis, companies are able to generate data on product use and refine products to meet the increasing need of end customers. It's ensuring that you are able to provide great customer service. And lastly, consumer access. Leading industrial companies also expand their offering by providing digital solutions such as complete data-driven services and integrated platform solutions. Digital business models are often focused on generating additional digital revenues and optimizing customer interaction and access. Digital products and services frequently look to serve customers with complete solutions in a distinct digital ecosystem. Part of this are personalized or customized products, which of course is more treasured by many customers. And the more people value a product, the more it increases the product and the organization's sustainability. As technology becomes deeply integrated in our lives, today in Industry 4.0, we now welcome the rise of smart technologies and smart cities. It's more than just about being clever, knowledgeable, or intelligent. More than what the word smart means, the smart in smart technologies and smart cities also stands for self-monitoring, analysis, and reporting technology. When referring to technologies as smart, we perceive their capability to perform semi-independently, meaning without much human intervention and physical interaction. Now, some examples of smart technologies that we have today are smartphones, smart TVs, and even smart cars, all of which can be accessed, controlled, and used digitally. Most of the things and gadgets that we are using in this age can be called smart. Smart technologies are all around us, not just in our homes, but also out there in the streets, in our office spaces, in malls, and even outdoor parks. We can find them everywhere and anywhere we go, thus building what we call a smart ecosystem, where people can interact digitally with their environment using their own mobile devices. This growth of smart ecosystems thus is paving the way to the rise of smart cities. But what are smart cities? Well, smart cities are places where different electronic methods are used to get and collect data in order to gain insights that could help improve, manage, and deliver services better. Through smart technologies in smart cities, communities can improve energy distribution, streamline and schedule trash collection, decrease traffic congestion, and even improve air quality. All of these sound really cool, huh? So why don't we have a look at some of the smart cities we have in the world? Let's check it out. First stop, New York City. In New York, they have Link NYC, a communication network that provides free, super fast Wi-Fi, phone calls, device charging, and a tablet to access city services, maps, and directions. Link NYC has replaced payphones. Next, we have Singapore. In Singapore, citizens can report municipal issues, hail self-driving vehicles, receive location-specific environmental alerts on air quality, temperature, and rainfall, and even access information tailored to young families and elderly residents. All of this possible through a network of apps. This is called the country's initiative called Smart Nation. Lastly, Barcelona. Barcelona is actually the first to have a public network of fabrication laboratories, which are small-scale workshops offering digital fabrication services. These Fab Labs are made accessible to citizens so that they can participate and contribute to the changes at a grassroots level. We keep talking about the advancement of technology as we enter each new era of the Industrial Revolution. We've learned about the great inventions from the previous ones, like steam engines in Industry 1.0, light bulbs in 2.0, and computers in 3.0. Today, in Industry 4.0, we are also welcoming a lot of new emerging technologies. But let's focus on the two that are making waves in the community: digital fabrication and robotics and artificial intelligence. Digital fabrication. What is digital fabrication? Digital fabrication is a design and production process that combines 3D modeling with additive and subtractive manufacturing. Additive manufacturing is also known as 3D printing, while subtractive manufacturing may also be referred to as machining. Basically, additive manufacturing is making a tangible 3D model from a digital file by adding layer upon layer of material. Whereas subtractive manufacturing is taking out a part or a piece of an object in order to create a tangible 3D model. So it's kind of like adding to create something or removing to create something. Now, with these two processes, it sounds like we can make almost anything as long as we have the digital file. And more importantly, as long as we have somewhere, a place to do these projects. Like, I don't know, maybe a fabrication laboratory or Fab Lab? Fab Labs can be found all over the globe. Fab Labs are places that inspire creativity, motivate creations, and cultivate meaningful partnerships between the community. With the Fab Lab, people can create solutions that would address the immediate concerns of the community. And this is all thanks to the digital fabrication technology and machines that allow us to make almost anything. From new and innovative designs, to endless customization and personalization of various products and items. What exactly can we find inside a Fab Lab? For additive manufacturing machines, we have our 3D printers. Again, 3D printing is a process of creating a tangible 3D model by printing a material layer by layer. With 3D printing, we can create prototypes of our products, or even personal 3D objects, like our own collectible figures. We can also 3D print useful tools and gadgets that can help us with our everyday living and activities. For subtractive manufacturing, some of the machines that we can find inside a Fab Lab are laser cutting machines, which can cut and engrave on materials without burning them, flatbed cutter routers, which are used to cut and engrave on paper-based materials and other light substrates or surfaces, making this machine ideal for cutting unique product packaging and boxes. CNC routers, which are more on the heavy-duty side. It can cut, it can engrave, and it can route, which is like drawing but using a drill, on big, sturdy materials like wood and acrylic to make furniture pieces and signage. And CNC mills, which are similar to a CNC router but have a more 3D function and can cut in a higher depth. These can also cut and engrave on wood and metal, making it ideal for projects that require these materials but require more 3D shapes. We also have various printing technologies inside the Fab Lab, like the print and cut machines. A printer and cutter works hand in hand and allows us to continuously print and cut our applications with little to no interruption. So, if you're making copies of hundreds of stickers, labels, or even posters, you can use print and cut technology. Let's not forget AI and robotics projects. As a workshop workspace, we can also learn and make AI and robotic technologies inside our Fab Labs. In fact, even here in the Philippines, universities and colleges are getting into AI and robotics with the help of their own digital fabrication laboratories. Using the Fab Lab's tools, machines, and technology, we are able to create many applications that benefit not only our communities, but also our local industries. In engineering, advancements in fabrication technologies enable engineers to build safer, more resilient structures. In architecture, digital fabrication allows architects to ideate their building designs accurately from the initial stages in the design process. In manufacturing, digital fabrication lets manufacturers create intricate and complex designs. It can help businesses save time on the preparation involved. Because of those benefits, digital manufacturing essentially allows small manufacturers to operate with more efficiency and with lower costs. AI and robotics are making groundbreaking changes in our society today. This is why it is now being introduced and taught in our schools, universities, and even Fab Labs. So, let's have a better understanding of what AI and robotics are all about. First, what is AI? AI stands for Artificial Intelligence. It's like a simulation of human intelligence that basically lets programmable machines perform activities and tasks that humans can do. Through AI, machines and other technologies are capable of doing things like problem solving, speech recognition, tracking, and planning. Next up, what is robotics? Robotics is a field of study that combines science and engineering and involves design, creation, and operation of robots. As you can see, robotics is not the same as robots. Now that's a common misconception. Robotics is the field of study, while robots are the programmable machines that can do human tasks with the help of AI. Yes, they are all connected, and through them, we are able to make high-tech applications that can assist us not only in our day-to-day activities, but also to make complex work easier and faster to accomplish. The emergence of smart technologies and AI and robotics in Industry 4.0 has led to the automation of various tasks, especially in the fields of manufacturing. We know that the digital transformation has planted fears in the minds of many, thinking that people, us humans, are soon going to be replaced by robots and machines. But contrary to losing jobs, AI and robotics will actually help us create more and even better positions, as well as higher paying job opportunities in various industries. As tasks become digital and automated, we in turn are able to focus on creating more innovations and on discovering new ways to further improve our community, society, and lifestyle. AI and robotics has been serving many industries like agriculture, healthcare, transportation, manufacturing, and even education. Wow, we've really gone a long way from steam engines in the first industrial revolution to discovering electricity and gas in the second industrial revolution, and from the rise of computers and mobile phones in Industry 3.0, and finally where we are now. Automation of many tasks and services, and the emergence of smart technologies and cities in Industry 4.0. Big changes are indeed coming our way, but fear not. As I've said, there are more opportunities in store for us as we continue to advance. Well, we've finally reached the end of our discussion. I hope you learned a lot about Industry 4.0 and that the things I've shared with you today have made you excited even more for the future. If you want to learn more about Industry 4.0, Fab Labs, AI and robotics, and digital fabrication, you can go check out our videos at Accelerating Maker's YouTube and Facebook page. And don't be shy to drop a question in the comments or message us. And that concludes our webinar today for Industry 4.0. Thank you very much.